Hello and welcome to my very first Virident online demo. And today what we're going to be doing is looking at how we can connect a simple flashmax 2 product, which is here on our website, flashmax 2 product, and attach that as a local drive. So this card plugs in the PCIe bus and attach that as a local drive to a traditional Linux server. And we're just going to go through the steps to do that. All of the information around the card itself and the specs of the card that we're using today are here and can be downloaded from our website. What you can see here is all of the performance numbers, and the card we're using today is a 550 gig and it's a standard product, so straight off the shelf. But you can even see for this entry point card, it's got some fantastic figures and numbers. You know, here we go, read latency 76 microseconds, write latency 16 microseconds. So I mean, this is just absolutely fantastic and is really taking the market by storm. Here are the operating systems that it supports, and this is where the type of connector that the card plugs into, obviously a PCI 2 socket times 8 for this type of performance. So let's go straight ahead and let's connect to the Linux box, and I'm just going to go straight in here and connect on. And this is a absolutely bog standard off the shelf copy of CentOS, obviously using a generic kernel. Same applies to Red Hat and all the other Linux variants out there as well. So let's start. So what's actually happened? So I've plugged the card into the server. The server now has the PCIe card, and we need to make sure that it can be seen by the operating system. So the first thing that we need to do is obviously run a ls PCI, and that will actually list us out all of the PCI cards that are on the board and basically all of its interfaces. So if we actually look down here, instantly I can see here is our Virident flashmax card installed, ready to go. So the next thing we obviously need to do is look at where we're actually going to install the drivers to actually access that card. And the next thing we do is just obviously to find the type of driver that we need, and we've got a thing here called uname-a, and that will actually tell us everything we need to know about the Linux kernel revision. And as you can see here, it's an x86 64-bit Linux kernel, and this is the driver that we need to download today. I've now downloaded the drivers onto the system, and I've actually copied them to the temp area, and you can actually see here in red there's 3 packages and files that I've copied down. The first one is called kmod-vgc, which is the physical driver. The second one is called vgc-utils, which is the utility driver that is used to manage the card. And the third one that normally is copied down is the VGC firmware, and this is the firmware that actually resides on the card. So if I was using an older card that had older firmware, I could uncompress that file and literally run a simple script in there, and that would update the firmware on my card. So the next thing to do is actually install the physical driver itself, and we run the command to do that, which is called rpm, and it's ivf install verbose. And basically what we're going to do is install the first driver. And you can see there that it says preparing packages for installation. And the next one we need to actually install is the VGC-utils driver. So it's exactly the same, rpm minus ivf, and no depths on this one. I'm using a slightly different driver on this one, and I'm literally going to basically install that now. And that's going to basically go off, expand the package, and install that, and it's come back and it's done that already. So now we've reached a point where both of these packages are installed, the VGC driver and the VGC-utils. The next one is to make sure they start at runtime, and basically to start the driver so it can actually access the card. So what I'm going to do is just type run level just to see what version, what run level we're running. We're on level 3, which is fantastic. And the thing I'm then going to actually look at is to actually start the driver, and I just simply type service, the driver itself, vgcd, and then start. And that's actually going to load up into the kernel those drivers that we've actually expanded, the RPMs, and then give me access to the card. Once they've loaded in, I'll then be able to actually load up and look at the VGC-utils for there and actually see the card. And it's really straightforward after that. We then just put a file system straight onto it, and then we can just mount that file system in Linux. So there it goes, and it's just come back telling me that everything's clean, green and correct, which is fantastic. The next bit I'm going to do now is literally just have a look at the card, make sure there is, and there's a command called VGC-monitor, and that will actually show me the card itself, and you can actually see there it's come back here and it's told me that we've actually got RAID enabled automatically on the card, and the additional options, the software options, vCache, VHA, vShare are disabled, because we want those disabled because we just want to use this as a local card. You can always check that both of the packages are installed and the service and the driver is started. So basically we can just type service VGCD status, and perfect, VGCD is running. So the next thing we want to do is, as I said before, is have a look at the card, and we're going to type VGC-monitor, and then we're going to give it a drive, and it's going to be /dev/VGCA, and that's going to tell us exactly all the details about the card. So the things like the flash reserves, the total of bytes and reads and writes. It's also going to tell you the revision, the temperature, and it's safe, 44 degrees C, which is good, and if any actions are required. And it can list out the partitions, VGCA, and obviously to access that we need to format that up and add a partition onto that. The card's mode also is in max performance. We could actually convert and tell the card to run in max capacity, and that will actually add additional space onto the card. We're now ready to then literally to leverage and use this partition on the card and to format it up using Linux to do that. So obviously we support all different types of partitions. You could format it with what particular partition you want. Lots of people use things like XFS, which is the highest performing file system out there on Linux at the moment, and absolutely will format that up, the card, in that mode. Today a customer was chatting to me and said actually you just want to use it in traditional ext3. So we're just going to basically use exactly the same around there. We're just going to put an additional bit of journaling on there as well to allow it, and select a block size. So it's really straightforward. Traditional Unix MK file system, MKFS, minus type ext3, and then literally what we want to do is put a block size, because obviously we're specifying that, so 4096. And then basically we need to specify a journal size, so capital J, and then size equals, and again depending on that I've done 600, and then literally the partition itself, dev/VGCA, and you can see there I'm just going to put on the partition number, there is 0, and just match that to the card. And that's now going to basically put a file system straight onto the card, and you can see it counting up and actually adding that in there. And you can see it adding the inode tables, and when it reaches the top, there's the journal that I've asked it to put on here, and we're literally ready to go. So the next thing we need to do is look at how we actually access that file system, and we can put that into the FS tab when this comes back, or we can manually just mount it now, which I'm going to show you at this moment. So let's manually mount this now. So let's create a directory, and if we go to MNT, we have a look here, you see there's nothing in our MNT, so I'm going to make a directory, and I'm going to call this flash drive, and then basically what I'm going to do is create a just mount this. I'm going to mount the type of file system, which we did as ext3, if you can remember, and then literally I'm going to mount /dev/VGCA0, the partition, and I'm just going to mount that straight onto the directory I've done here, /MNT/flash drive, and it's mounted it, and then I can literally CD to my MNT flash drive, and here we are. The card is ready to go. If I do a df-h, you can actually see there's the card mounted, and the flash drive is ready to be accessed by Linux. All of the information and bits and pieces can be found up on our website, and you can obviously look at the products and the solution stacks that card can be used for on Linux.